Hello, fellow decision scientists. Today we are gonna do the last section of chapter 6. So far we have done 4 sections of supply chain models, assignment problem, shortest route problem, maximal flow problem, and today we are gonna do a production and inventory application. The first point that might strike your head or mind is this point, that network models or distribution models are not only related to transportation and transshipment models. In fact, it can be applied to some problems that have nothing to do with transportation or physical movement. As you can see in this slide, it is mentioned transportation and transshipment models can be developed for applications that have nothing to do with the physical movement of goods from origins to destination, except assignment problem. All the problems that we have done so far had something to do with transportation movement, and this time we are going to do an inventory problem, inventory and production problem with network models. But before we start our case, let me give you some examples, or in better words, some sort of introduction to production and inventory applications. First of all, we all are familiar with the concept of inventory control. For example, when you go to a store and decide to buy 3 bags of bread, you're not gonna eat all 3 bags in a day, usually. When you buy 3 bags of bread, maybe you are stacking bread for 1 week. Or let's go for other things. For example, when you go and buy, for example, 20 pounds of rice. Okay, maybe it is your inventory of rice for 6 months, 3 months. So this type of thing are inventory control problems. Why you don't get 1 bag of bread? Because you don't want to go to the store every day or every other day. That's the reason when you go, you buy 3 bags, 4 bags, 5 bags, and so forth. In fact, you are finding a balance. Why? Okay, if it is the case, why don't you buy 10 bags of bread? Because they are gonna get expired. They are gonna get spoiled. So I gave you these simple examples to make you familiar with the area that we are going to discuss together. And before everything, I want you to make sure that you are not alien to this area. You completely know inventory control and you do it in your everyday life. Now, about production and inventory application, what's the case here? Imagine we have 3 seasons. Season 1, Season 2, and Season 3. I guess I said 3 seasons. I hope I'm right. Okay, we have 3 seasons. In this 3 seasons, we have a demand and also we have cost of material. Okay, very simple problem. And also we have storing cost. Storing cost. So we have 3 seasons. We have cost of material and we have store cost and demand. What would you do if the cost of material in season 1 is $1, but in season 2 it is $100, and in season 3 it is $1,000. Just I make it this much magnified because I want you get the point I'm alluding to, I'm referring to. So you see, cost of material for each product in season 1 is 1, season 2 is 100, and season 3 is 1,000. So here, and assume demand is equal for everyone. Demand is 100. So the first question that comes to your mind is that when the cost of material at season 1 is this much cheaper than the other 2 seasons, why I don't make all the demands of season 2 and season 3 now? Because in the explained problem, I didn't talk about any limit in production ability. So we can manufacture any number of product that we want because there is no constraint in this regard. Okay, so let's in season 1 make 300 of that product. Why? Because the cost is very cheap, and I'm gonna keep it 100 for season 1, 100 for season 2, and 100 for season 3. Makes sense. First problem. What about expiration? Expiration. For example, they are maybe materials that get rotten. What about that? Let's assume that there is no expire time, or at least there is no expire time for 2 years. So we are good in this regard. Another question, what about the storing cost? What if the storing cost for each season is 1 million? And I told you, I'm just making sort of magnified numbers because I want you to understand the point immediately. Because when the storing cost of each product for 1 season is 1 million, it is much better to make the product at the same season that you want to sell them. So you are not gonna store any of them. So you see, but imagine the storing cost is 0. It makes sense. Okay, let's make all of them for them. What about 10? We need to think about it. What about 50? We need to think about it. That's the point of production and inventory applications. Because we all know in real life, always the price are changing. The cost of material are changing, storing cost are changing, and all of those things are changing according to demand. It is the case in production and inventory applications. Now that you have an understanding of production and inventory problems, let's do a case together, similar to the previous sections that we did together with good results according to the feedbacks I'm continuously getting from you. We are going to do it exactly in the same way. We are going to talk about a case and we start modeling it with activities one by one according to the steps we usually have. The case we have here, Contois Carpets is a small manufacturer of carpeting for home and office installations. Production capacity, the one that we talked about in the previous page. Production capacity, demand, production cost per square yard, and inventory holding cost per square yard for the next 4 quarters are determined. Production capacity, demand, and production costs vary by quarter, whereas the cost of carrying inventory from one quarter to the next is constant at 25 cents per yard. Contois wants to determine how many yards of carpeting to manufacture each quarter to minimize the total production and inventory cost for the 4-quarter period. Okay, the problem is explained in a way that I guess you quickly got what is the objective function and what are decision variables. Regarding the example I gave you, regarding the magnified example I gave you in the previous page, you should have a good understanding of these points that are being talked here about. Okay, it talks about a manufacturer. It doesn't help us. It has no value. Okay, in the previous example, we said production capacity is unlimited. About the demand, we said 100. It is something else. Production cost per square yard, we talked about it, that 100 and 1000. And inventory holding cost is exactly as storing cost that we talked about. And another thing is the transportation cost. Production capacity, demand, and production cost vary by quarter, whereas the cost of carrying inventory from one quarter to the next is constant at 25%. So my friends, the only cost that is constant and is not changing according to the quarters are inventory costs, or let me tell you in better ways, it is storing costs that we talked about in the previous page. So storing cost or inventory holding cost are the only cost that is constant and doesn't change from quarter to quarter. And now with these things that we have, 3 changing costs per quarter, we need to decide how much we need manufacture in each quarter and how much we need to store to be used for the coming quarters. That's the main question that we are gonna do.